Hello, my name is Lloyd Jackson.
My name is Freeman Tala.
And my name is Mitchell Griffin, and this is our solar tracker project.
Yep. So first of all, we have the actual tilt panel, which will feature the solar panel, and our sensors, our light-dependent resistors that will actually determine the position of the sun. And if you look on the bottom side here, you can see the actual tilt mechanism, the motor that will actually be turning that, as well as the encoder, which will be sending feedback to the Raspberry Pi, telling it where the position is currently. So the purpose of the solar tracker is to follow the sun and position itself so that it may gain or collect the most amount of energy. So the purpose of the limit switches, one in the front and one in the back, is to limit the actual tilt mechanism of the solar panel from roughly 10 to 2.
Design pretty simplistic and user-friendly. Actually, we got the power button to actually turn on and off the device. We got a fixed switch to display either power or energy on this 4-digit 7-segment display. We got a halt button to pause the system for emergencies. Now we got this switch to select either auto or manual mode. Actually, our system will be in one of these modes, either auto or manual. The auto, the panel, the tilting will be monitored by the program running in the Pi. And in the manual mode, you'll be free to monitor the position of the panel using this button: forward, reverse. The LCD is gonna be displaying basic messages and the system status. Here we're gonna be having some LEDs to indicate the system status, either OK or low battery. And then we gotta have a reset button for software reset. Thank you.
To better understand how the solar tracker works, let's take a look at the inside. So first of all, the solar panel's power comes into the capacitor bank, and then it afterwards feeds into the DC to DC converters, which regulates the power, which then feeds into the power distribution board. Afterwards, we see the Raspberry Pi, which is the control center for all the signals, through the ribbon cable, gets distributed to the main PCB board, which distributes all the signals to all the different devices. Another important component of this system is the analog to digital converter. It converts the analog signal of both the current as well as the voltage sensors that will be in the system into a digital format, which will then feed into the Raspberry Pi. Afterwards, the Raspberry Pi will make calculations in order to determine the power and the energy of the system. So in order to tilt the solar panel, we have the motor driver, which controls the motor. The encoder is here in order to send signals back to the Raspberry Pi in order to confirm the position.
So why is the system not very used today? Initially, a couple of reasons account for this. One, the initial cost of setup is higher since it requires moving parts. Two, it needs maintenance and upkeep since it's an outdoor system. Power for the equipment, in order to keep it moving, comes from the system itself. It's self-sustaining. So just imagine, it will be a loss if you need to incorporate the tracking system on the panels we use everywhere in town.
Well, this is our D3 project, Group 10. Thanks for watching.